Okay, so welcome everyone to the OCP Tech Week. We'll start with the TAP kickoff. So the TAP project basically stands for Time Appliances Project under the OCP. And here we have Michelle and Elad. So we'll start with the overall of the presentation, which we will go through the vision.
To the speakers, if you don't mind muting your FN too. Thanks.
The tap. So Rajiv, do you want me to start from beginning? You're muted. Rajiv?
Ahmed, you're good. Please carry on. Everything is good.
Yeah. Okay, sure, no problem. Okay, so yeah, we'll go through the vision, background, and the mission statement, the scope of operation, and the work streams. So overall, in terms of like the vision, we thought of there is the need for the next generation of data centers to go from an asynchronous perspective to a synchronous. So we call them as synchronous distributed systems. So the question comes basically into how should we do this and why should we do this? So we basically handled both these important parts of this mission equally in the same time. So we looked first in why we need these things, because it's better to look for the needs and justification of, let's say, going with a technology, in the same time, the feasibility of it. So we started with looking at like services that they can get this boost from synchronicity. And we realized, like, for example, message services can get simplified to at most one scheme to guarantee basically like like on a distributed basis, things can basically flow smoothly. The authentication can go from, let's say, minutes to milliseconds, if not microseconds, based on accurate time, if you have accurate time distributed across the network. Cache consistency, which basically comes from synchronized invalidation versus basically communication. So overall, it's been taught for years, basically in academia, that distributed systems are in nature asynchronous, and that is always like the first bullet point, that you don't have a common clock. But now we are trying to explore what will happen if you have this clock, and what advantages you can take basically for your system from this synchronicity. So also some other techniques, such as like decoupling from the network latency to basically get a higher throughput by reducing the wait time in order to basically create linearizability and so on, which again, we'll go through a lot of talks today to cover these things. And it's not a new thing with Google Spanner and the concept of a data center like a PC with performance boosts close to like 100 times in throughput. This is a concept that has been explored for a while. The commit windows also can basically get accelerated and simplified when you have, in a distributed system, when you have this coherency of time across the fleet. So for instance, a lot of times, like, you have these, the issuing machines being like across the, let's say across the ocean, and then you have, like, let's say the machine in US, and then you have things like in Europe or in Asia, like another data centers, and then the write commands should basically be issued from one machine across the ocean. You can avoid that if you have this like coherent time across the globe. So also, like, the growth of edge services shows us that it becomes vivid and more important over time that you have this accurate time available to all these nodes, because then you can provide a lot of these things in a much smoother way. So overall, we are calling it so that the accuracy of the clocks across the systems will reduce the need for things to move around. So TAP's like background can be basically broken into different industries. For example, anything that requires this high accuracy and reliable distribution and synchronization of time across packet networks can benefit from these things. This ranges in a lot of sectors in industry. And I will hand it to my colleague, Michelle, to give you a deep dive in some of these examples.
Yeah, thanks, Ahmad. My name is Michel. Like Ahmad was saying, there's several vertical industries in the past decade that have embraced the need for high accuracy and reliable distribution of time and frequency across packet networks. Although all of them have different use cases, and the table below shows a couple of these vertical industries. One of the common theme across these is that they all make use of, for instance, a protocol like IEEE 1588 or PTP. Furthermore, all of these industries actually have specified what we call PTP profiles, and we'll cover that a little bit later in a different presentation, to allow each of these industry to make use of PTP and to define their own set of for functionality for their own applications. Next slide, please, Erad. So basically, what has happened in the past 10 to 15 years is that the use of 1588 and the definition of these PTP profiles across these industries, they've produced a wide number of contributions that basically have advanced the subject of timing and sync, although timing and sync is not new, but timing and sync over packet networks here. For instance, there's multiple standards organizations that have produced a large number of specifications. There's that have led to the semiconductor companies to embed PTP very deep into the hardware. Another fact is, for instance, the test and measurement equipment vendors are now producing equipment where you can measure accuracy with or some nanosecond accuracy, and create various types of impairments to replicate a bit what is going on with packet networks, and how it impacts the distribution of time and frequency. Oscillator companies also, for instance, have pushed the boundaries of performance of quartz, OCXOs, DCXOs, and so on. Now, the open source community also, there's a growing popularity and a growing need to use Linux PTP, and the various tools that have been built around Linux PTP across these vertical markets, whether it's telecom, industrial, automotive, and so on. There's also various types of events that exist in the industry, whether they are what we call plugfest type of events or interoperability events, that really push the time, those technologies and various types of innovations. And although this world of synchronization is a very small world, actually, there's a really good body of well-known technical conferences also on the subject for this community to really capture and share the learnings. So essentially, the Timing Appliance Project, we intend to basically leverage all of this wealth of information that exists across the various work streams that today we're going to be going through and explaining, what those work streams are all about. Next slide.
Hi, I'm Elad. And for the TAP, we have set up this vision statement following the background and the vision we laid out. The mission is quite simple. We want to leverage on the community that we established already around TAP, and to leverage on the industry that we referenced in order to bring specifications and references for data center timing appliances, data center timing applications, and the network infrastructure that is required to maintain those. We're gonna leverage on the IEEE 1588 predominantly. We're gonna look at timing and synchronization on packet networks. But the idea here is that we're gonna build these references which are open and are available to consume by the industry. We're also going to promote openness in timing appliances. The openness will come through open sourcing our implementation, so leveraging as much as we can on the OCP body, on open source projects to have these time appliances ubiquitous in the data center. The way we're going to do that is with bringing together that community. We already have a large number of participants and companies who are involved, whether they are vendors or operators and developers, and we're looking to add more of those as we continue with the work streams. We're gonna coordinate that work together with other OCP projects, the networking project, the server project, Edge and Telco, and there are others that all come together when you think of in data center timing appliances and what it mandates. I think the last thing that we need to do is we will promote time-sensitive data center applications, the promotion of these applications, bringing them into maturity and making them ready to consume by developers is another way for us to promote our mission statement. There are already very relevant topics for everyone to come in and join. There are 3 work streams which we'll go into the details of later today or on our website. But you can come and already sound your voice and help us build those. There's a major activity going on around data center PTP profile led by my colleague Michelle, and we're working on different implementations that are needed in order to have a PTP profile for the data center use case. We're going to tune it and we're going to make it consumable by our partners. And there is another stream for open source Grandmaster. In fact, we have a lot of announcements around that today. So the architecture of it and the building blocks of that is something that we're going to shape together. And open source implementations that are mandatory for bringing this vision together. These are all things that are already in flight, and we're going to present today the progress of them and present how to join us. There are other things that we have planned for later as we go into 2021. We're going to look into component selection, oscillators, clocks that we need to use. We're going to look into reference designs and build those for ready to deploy solutions. And there's a lot more that we rely on you to help us build. So if we want to conclude this kickoff, first start by visiting our website, ocptap.com. That's the wiki page that we maintain with all the relevant information, and join our mailing group, the OCP mailing group, and there are links to it from the website or from here. The next meeting for you to join is going to be Wednesday, this coming Wednesday. There are every other week, bi-weekly cadence at 11 a.m. Pacific time. So that's when we meet, and we look forward for your participation and your contributions in the TAP work streams. I'll open the floor now to questions and participants who want to sound their voice. Rajiv, are there any questions so far?
I didn't see it in that tool, so I think you're good. You did pretty cool.